Okay, so here's a Chapter 7 review that you should have already tried on your own. So I'll be going through this pretty quickly just to make sure that you did the problems correctly. But like I said, you should have done this on your own already, okay? So the first question is, in Maryland, 28% of all high school students own a car, and 5% own both a hoverboard and a car. What is the conditional probability a Maryland high school student owns a hoverboard given that he owns a car? Okay, so conditional probability. If we remember right, this is whenever we're given some condition to work with. So this formula would be the probability of A given B, where A and B are just some event that's happening, is equal to the probability of A and B happening over the probability of just B, which is what you're given, okay? So in this case, we have in Maryland, 28% of all high school students own a car, and 5% own both a hoverboard and a car, okay? So the first thing you want to do is okay, what are we given? So that would be the probability of the B. That's what we're given. Right here you see it says given that he owns a car. So if we wanted to write this out, we can say, okay, what is the probability of somebody owning a hoverboard given a car? All right, so that's the probability of owning both over the probability of owning a car. So we know that whoever the person is that we randomly select already has a car. What's the chance that all those people who have a car also own a hoverboard? That's what we're going to calculate here. So given car, that is the probability of B. Okay, and that's what goes on the bottom. So we know that the probability that they own both a hoverboard and a car is 5%. So if we were to start simplifying this, probability of somebody owning both a hoverboard and a car is 5%, and all the students who own a car is 28% of them, which I'm going to write that in black just so you can actually see it here. Very gray. 28% of students own a car. Okay? So now if we divide that, sorry, I'm definitely yawning through this video this morning. If we divide that here, we get 0.1785, etc. If you multiply that by 100, that will give you the percentage. Whoops, I forgot to say answer times 100. 17.8, and I would round that 5 to a 6 because of that 7. So 17.86%. 17.86%. And you could have also written as a decimal, but I always like to put it into a percentage. It makes it a little bit easier for you to see it. Okay? So number 2, a recent survey of 300 students, so we had a total of 300 students who were surveyed, found that 172 of them take biology, 182 of them have a pet at home, and 15 are not taking biology and have no pet at home. So we got to fill in the blanks in this two-way table. Well, we know that there's 300 total students. So if you look at the totals, that 300 is going to go right here. Okay. And then we know that 172 of those students are taking biology. So that's total. It's not going to go in either of these because those specify those taking biology either having a pet or not having a pet. It's going to go right here in the total. Taking biology. Okay. And then it says 182 have a pet at home. So again, it's not going to go here or here because that specifies those who have a pet taking biology or not taking biology. It's the total number of students who have a pet at home. So it's going to go right here. And then it says 15 are not taking biology and have no pet at home. So you want to see where those two things intersect. So here's not taking biology is this column. No pet is this row. So where those two intersect, that is where, oops, 182. This is where the not taking biology and no pet at home number is going to go. At 15 here. Okay, so now you have to fill in the blank. So if you have not done this yet, please pause the video and oh my goodness, and do it yourself. I keep yawning. I'm exhausted this morning. Okay, so hopefully you paused and did it yourself. But here, if you do 300 minus 182, that's going to give you this number here of how many students do not have a pet total. Okay, so we know 182 do have a pet. So if we were to subtract this here, we're going to end up with 118 who do not have a pet. Okay, and then you can do the same thing here, right? So we have 172 total students taking biology. So if we subtract that from the total number of students here, we're going to end up with 128 who are not taking biology. And now what we can do is find this one and this one. So here, out of not taking biology, 15 of the students not taking biology do not have a pet at home. So 128 minus 15 is 113. So 113 students who are not taking biology do have a pet at home. And I'm getting that from these over here. Everything lines up. Okay. So now here for no pet, you see here we can use these two numbers. Okay. So here it says taking biology, but they have no pet. All right. So we want to do 118 minus 15. So what is 118 minus 15? You should get 103. So 103 students who are taking biology do not have a pet at home. Okay? And that's just out of this random group of students. So now we just have to find that last bit, and you can either use this here, or you can use those who have a pet here to subtract and find that number. Okay? I'm just going to go and do this one. So out of those taking biology, we can do 172 minus 103 to find the number of students who do have a pet at home. So 172 minus 103 should be 69. Okay, and then you would want to make sure is 69 plus 113 182. And it is, right, if you were to use that in your calculator. So now we have that all filled out. So now we have to answer part B. What is the probability, I always like to start setting it up. What is the probability that a student takes biology given the student has a pet dog? And in this case, just put has pet, because that's what we're looking at here. It doesn't matter what kind of pet, it's a pet. Okay? So again, whenever we have this, we need to know the probability of having both biology, taking biology, and having a pet over the probability of just having a pet, because that's what we were given. Okay, so we were given that they have a pet, so that's what goes on the bottom, because we're only looking at the total number of students who have a pet. So what is the total number of students who have a pet? I'm going to erase this and put a different color highlighter. So I want you guys to look right now and see how many students have a pet. So we'd have to look here, a pet. We have 182 total students who have a pet. Okay, so on the bottom there, we're going to have the number 182. Now, how many students have a pet and are taking biology? Okay, so now we have to see, okay, well, how many students have both a pet and are taking biology? Well, we want to look at taking biology and pet. Where that intersects is at 69. Okay, so that means that 69 students have a pet and are taking biology. So now you have to divide that. So we have 69, and let me put this into projector mode. 69 divided by 182, you get 0.379. You can either move the decimal to the right twice or multiply by 100 for it to do it for you. So about 37.91% of students have 39, let's see here. 39.71% of students are taking biology given we know they have a pet. Okay? So out of the students who have a pet, 39.71% of them are taking biology. And that's it for that one. All right, here we have a parallelogram. So you want to use those notes that I gave you guys that were color-coded and gave you all the properties of a parallelogram. So here it says, if the measure of angle 2 is 5x minus 28, and the measure of angle 3 is 3x minus 16, solve for x. Well, we want to look at what do we know about angle 2 and angle 3. So look back at your notes from whenever I first introduced the properties of quadrilaterals. You should know that these two are supplementary. They add up to equal 180 degrees. So I know that angle 2, 5x minus 28, plus my angle 3, which is 3x minus 16, equals 180 degrees. So first you got to combine like terms. We have 8x. Negative 28 minus 16 should be negative 44 equals 180. Right? 28, 16. Yeah, 44. Making sure I'm doing my math in my head right. All right, so now what you want to do is add 44 to both sides. Okay, so we have 8x equals 180 plus 44, 224. I'm going to move this up just a little bit because I wrote too big. So now you have to divide both sides by 8. Okay. Yeah, 16. I'm just being lazy, not wanting to go over to my calculator. So it should be 28. Okay, so x equals 28. And that's what it said. It said solve for x. Sometimes it would say, all right, so what is the measure? And then you'd have to plug in x back up here into these equations there to solve for the actual measurement of the angle. And then if you needed to do that, you should know that angle 3 is equal to angle 1 and angle 2 is equal to angle 4 because they are opposite angles in a parallelogram. All right, so number 4 says solve for AM in the parallelogram if PN equals 9 and AO equals 4. So let's label those things here. So we know AO is 4, PN, the whole thing here is 9, and we want to find AM, which is this one here. I'm going to erase that 9 because the 9 does not matter here. If you look carefully at the properties of quadrilaterals, they state that the diagonals bisect each other, not that the diagonals are congruent. Okay, so the diagonals here bisect each other, so those are the sides that are equal. All right, I'm going to go back and make sure that I used a new properties. No, not that one. Let's see here. So this is the one I was talking about, you guys going back to. Yeah, so here you see that the diagonals of a parallelogram bisect each other, so they cut each other in half, but you guys see here that they're not equal. if they were equal, they would each have the same number of dash marks there. So they bisect each other, so this half equals this half, and this half equals this half, is what we're looking at. And then you can also see there how all the consecutive angles are supplementary here. They all add up to 180. Okay, so this is the sheet I'm talking about you going back to look at. All right. Okay, so if they're equal on each side, this one's pretty straightforward. If you used your notes on properties of quadrilaterals, AM equals 4. Done. That's just knowing a property. Okay. So here's another two-way table. These are really good to practice, and I provided one for you. Now on the test that you guys take for this chapter, you probably have to draw your own tables. So make sure that if it's talking about all of these different types of probabilities happening, or something happening at the same time or never happening at the same time, etc., draw a table, okay? So here we go. So a recent survey of college freshmen, 35% of students checked the box next to exercise regularly. Exercise is so important. 33% checked the box next to eat 5 servings of fruits and vegetables a day. That's also important. And 57, oh, that's a lot of people. 57% checked the box next to neither. Oof, that's not good. Okay, so definitely make sure you're taking care of yourself if this tells you anything. Okay, so we know we're talking about students who either exercise regularly or they don't. Okay, and students who either eat the 5 servings of fruits and vegetables a day or they don't. So let's label that. So we have, so I'm just going to kind of simplify it down to exercise and then no exercise. And then we'll put 5 servings. Gotta write that a little bit smaller. 5 servings. No 5 servings. And you guys know we're talking about 5 servings of fruits and vegetables, but just to save space, we'll just simplify it like that. And then over here, of course, we have the totals of the rows and then the totals of the columns. Okay? So let's start filling in what we know. It says here that 35% of students check the box next to exercise regularly. So the total kids who exercise regularly is 35%. Okay. And then we have 33% who check the box next to eat 5 servings of fruits and vegetables a day. So here, who do eat the 5 servings is going to go in that total. They eat the 5 servings of fruits and vegetables a day. That's a hard thing to do, but definitely try to do it. Give it a shot. So 33% of students eat their 5 servings of vegetables a day and fruits. Okay. 57% check the box next to neither. So that's going to be where no 5 servings and no exercise intersect, right there in the middle. So right here is the students who don't exercise and who don't eat healthy, okay, or eat their total 5 servings. All right, so here we have 57%. So this kind of trips students up sometimes whenever I would present this as a team test or something for them to do together. Well, if we're looking here, we need the total of all totals, like we need the main thing. But if we're working with percentage, what is the total of a percentage? What is the maximum total of something we're talking about? What percentage would represent all of the students who have participated in the survey? It's going to be 100% of students. 100%. Okay, so from there you start to subtract. So this one is how many total students do not exercise regularly? That would be 100 minus 35. So 100 minus 35 is going to be 65%. Okay, and then over here for the students who do not eat their 5 servings, it's going to be in this box, the total number of students who do not eat their 5 servings a day. 100% minus 33% is going to be 67%. Okay? And now you can start to find the other missing pieces. So here, no 5 servings a day. We got to find out right here how many students exercise but do not eat their 5 servings a day. 67 minus 57 is 10%. And then you can even just start going up like this. Whoops. So how many total students exercise? This one is 35% total. 10% of them do not eat their 5 servings. So that means 25% of them do eat their 5 servings of fruits and vegetables. There we go. And then here, this one you can use, either this way or that way. It does not matter which one you use to find it. So I'll just look at the 5 servings. So 33% of students do eat their 5 servings a day. 25% of them exercise. So that means 8% of them do not exercise. All right, so now this is all done, part A. Part B, what is the probability that a freshman in this study exercises regularly and eats 5 servings of fruits and vegetables each day? This is something you just have to look at your table for. So look at your table and see who exercises and who eats 5 servings a day of fruits and vegetables. Should see it right there. That's their intersection, is what we would call that. 25%. Done. No math involved for that one. Okay, so the table tells us that directly. So part C, it says, what is the probability that a freshman in the study exercises regularly or eats 5 servings of fruits and vegetables each day? This is the addition rule. With that or statement, that means we're using the addition rule. You can look back in your notes to find it. It is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of both of those happening at the same time. Okay? This one's nice because we already have everything in percentages, so you don't have to worry about writing anything as a fraction. Okay? They're already in percent, so that's perfect. So here we know we want to find the probability of exercises regularly or eats their 5 servings every day. So the probability of exercising, I'm just going to put probability of X, probability of exercising plus the probability of the 5, I'm going to write servings because I don't want students to ever write a number inside of there, plus the probability of eating 5 servings minus the probability that they do both. So let's see here. The total number of students who exercise is what's going to go here. The total number of students who eat their 5 servings a day is what's going to go here. And the total number of students who do both of those, exercise and eat their 5 servings, is here. And we already have all of those numbers highlighted in the table above. Okay, and that was just a coincidence that they gave us the total number of students who exercise and the total number of students who eat their 5 servings a day. They could have given us other numbers to find everything else, but they give us those. So this is going to be 35% of students exercise plus the 33% who eat their 5 servings, but since they were double counted in each one, the students who do both were double counted in exercise and eating their 5 servings, we have to subtract that number out. 25% do both. So 35 plus 33 is 68 minus 25 is 43%. And that's your answer there. Okay. So now let's see what we have left here. So we have a few review questions and then expected value. So I'm going to set these up. So number 6, you use the zero product property for part A. So we're going to have x minus 5 equals 0 and x plus 2 equals 0. Solve for x. What is x? You can do it. Part B, the first thing you need to do is set up your x here, like that. X squared times 24 is 24x squared. And the negative 10x is what goes on the bottom. So you need to find these two factors here and here, and then factor it using your area model. So as long as you can find the two factors, and I know you can because I know this one is factorable because I made this problem. So this one is factorable, so you don't have to worry about completing the square or the quadratic formula. You can factor with the basic factoring methods we know. So just remember, x squared and the 24 have to go across from each other in the table. And then your factors that you split in the x go here and here. And then you need to find the factors. Once you find the factors, you set each factor equal to 0 and solve for x. So I might have written too big here, but just know that this is the process. So you guys can pause the video now, do it on your own. I'll go ahead and make it smaller just so you know you probably need to make it quite a bit smaller to have room to do all the work. Okay? Alright, so now for completing the square, you guys should find the steps that we've done them because you need to review it. But I'll do the first step. So the first thing is to add the 10 to both sides. So then you're going to have x squared plus 6x blank equals 10. And then you need to add the b over 2 squared to both sides. So our b here is 6. This is our b. 6 over 2 squared is 3 squared, which is 9. So we're going to add 9 to both sides. And again, I'm going super fast, so please pause the video. Find your notes on this because this is so important for you to review. Do not ignore my request for you to find your notes on this, okay? Find the notes on completing the square. I'm sure they're in Google Classroom somewhere. You'll either find your own notes you did in Kami, or your notes might be in a notebook, or you can find my notes that I posted on Google Classroom after class, okay? So now you got to rewrite this. Now that we completed the square, you write it as a perfect square, like that. So we have x plus 6 over 2, which would be x plus 3 squared. So you guys are going to have x plus 3 squared is the perfect square of that, equals 19. So now it says for each equation below, solve for x. So you still need to solve for x here. So what you want to do is take the square root of both sides. Remember, this is plus or minus. So now we have x plus 3 equals plus or minus square root of 19. I'm going to make everything a little bit smaller here. Okay, so now if I were to subtract 3 from both sides, we have x equals negative 3 plus or minus root 19. And you could totally get that to be a decimal and find each of your two answers by splitting the plus and minus. So I want you guys to do that on your own. Split the plus or minus and put it into your calculator to get the decimal. Alright, quadratic formula. First thing is you have to find your a, b, and c. So here I know a equals 2, b equals negative 5, c equals negative 8. You want to look back in your notes how we would do this. A lot of you did not struggle with setting it up. You struggled with simplifying it. So you definitely need to make sure that you are very careful with how you set this up. Okay? So this is, oops, I should not be writing that. I should write the actual. So this is negative b plus or minus b squared minus 4 times a times c. And I would put parentheses around all of those. All over 2 times a. So what I mean by parentheses over all of those would be if I rewrote inside minus 4 times a times c. Okay? And make sure you don't forget about any negatives or anything, but honestly, guys, like if you were to split the plus or minus, you can write it exactly like this in Desmos. Just do one of them as plus the square root and one of them minus the square root to solve for it. but just be really careful with your plugging in the negatives. Okay, so now very quickly, because I have to get ready for work, find the expected value. So we have 60 degrees here. We know the whole circle is out of 360 degrees. So that's that fraction. We know that this is 180 degrees. So if this side here is 60, 180 minus 60 is 120. So we know that one is 120 out of 360. And then here we have a 90-degree angle. So that's 90 out of 360. And once again, since this whole thing here is 80 degrees, 180 degrees, this one here must also be a 90-degree angle. 90 plus 90 is 180. So now what you guys have to do is take what this is and multiply it by each other. So I'm just going to go and kind of color code a little bit here. Those are the values of the section, and those are how much the section is of the whole circle. The 90 over 360 is how much of the circle it is. So here we have 60 over 360 times 10. And then we'll do the blue one next, plus, it doesn't really matter at all what you do next, but plus 120 over 360 times 1, plus 90 over 360 times 2, plus 90 over 360 times 5. So if you remember right, you can just put all of these over 1 and then multiply straight across. So 60 times 10 is 600. 360 times 1 is 360. 120 times 1, 360 times 1, 90 times 2 is 180. 360 times 1 is 360. 90 times 5 is 450. 360 times 1 is 360. Now you guys can plug this into your calculator to find the final answer. You could also add up all the numerators in order to get whatever it all is over 360, right? Add up all the numerators. So that would be 600 plus 120 plus 180 plus 450. And then that number goes there. Divide that by 360 and you'll get a decimal probably if it's not a perfect whole number. And that's your answer. But know that whenever I'm grading these, I'm not going to give you credit unless you got the final answer, okay? Especially for the ones that we're factoring up above, because I did most of the work. So I hope you guys had already done this and this is your way of checking your work, making sure you're good to go. Okay? But I'm going to go ahead and upload this to YouTube now, so hopefully this helped you prepare for your Chapter 7 EST and the problems that will